Welcome to Developer Service YouTube channel. On today's episode, we're going to be talking about mutable objects in Python and also how problematic the mutable objects can be as arguments for functions if used in the wrong way. First, let's start with examples of what is mutable objects in Python. Well, mutable objects are objects that can be changed after they're created. For example, a list is a mutable object. As you can see here, I define a list. My list contains 1, 2, and 3. These are elements of the list. I will be printing the list itself, and I can append to the list. I can append number 4, and with this I will be modifying the list. And if I run the code, you can see on the original list 1, 2, 3, 4, and I modified the list by adding another element to the list. Another example of mutable objects is a dictionary. In this case, I have a dictionary here called mydict, which has name, which is John, age 30. This is the original dictionary. I'm going to append a new key value pair to the dictionary, or add a new key value pair to the dictionary called with the key city, New York, and I'll be printing that. So if we see the example, the original dictionary named John age 30 and named John age 30, now it's city, New York. So I was able to modify the dictionary. And finally, another example of mutable objects in Python is a set. And the set is similar to a dictionary, except none of the elements inside the set can be repeated. In this case, I have 1, 2, 3, and I can add the number 4, which is adding a new element. And again, it's going to be changing the set if I run this. Original set 1, 2, 3, and modified set 1, 2, 3, 4. As an example, if I would state here that I want to add another 3, and if I would try to run that, you can see that the set maintains the same. It does not add to the set itself because it contains one element of each. One element can be unique, so adding another 3 just means I have a 3, but still it is a mutable object. Now that we know what is a mutable object in Python, let's discuss why and how the mutable objects as default arguments in a function in Python can be problematic. And they are problematic because they are shared between the different function calls. For instance, if I define a function, which I'm calling here wrong way, and if I define a default mutable argument, in this case items, which is an empty list, this will be problematic because it's a mutable default argument. And if I try to append, I will be able to append, but you will see what is the problem. So if I run the code, I'll be calling the function one time and then calling the function a second time. And let's see what happens. So I call the function the first time, it has 1 because it is the first append, and I call the function again, it has 1, 1. So it actually reused the previous list that was the list for the first call, added the 1, and the second call added the other one to already existing list. This means that this list was persistent between the different function calls. And why does that happen? That happens because this list is actually created when the function is defined. So at this moment that we are defining the function, this items list, it is created and not when the function is called. So it immediately creates this items list, and that's why it exists as a variable, let's say. And when I run the two different functions, I'm actually appending to an existing items list that is immediately created when I define the function. And see an example with dictionaries, where I have also a default argument, which is mutable, dictionary, and I'll be changing one of the keys called count, and I'll be just incrementing that count and returning that. So the same process as before. I'll be calling the same function twice, and if I call it, you can see that the first call count is 1, second call count is 2, which means that the dictionary with the value count has persisted between function calls, again due to the same problem. This dictionary is immediately created when the function is defined, so it exists already, and not when the function is called. So that means that it exists as a variable that is being incremented each time that we call the different functions, or between the different function calls. So you might be asking, what is the correct way to solve this issue? Well, let's take a look at the correct way to solve. And here we have the example. And the standard practice in Python, it states that you should be using none as a default value and creating immutable objects inside the function. So let's see that as an example. I have here the same function. You see I'm receiving again the items, but this time I'm saying that the default value is none. And inside, if the items is passed as none, then I'm going to be creating the list inside the function and then appending. And if I demonstrate that I'll be calling the function again twice. And if I run, let me just expand this a bit. You see, I call the function the first time, it's 1, it's just appended that one time. And I call the second time, it's just append, because it is the items is none, so it's actually not assigned to anything. And each time that I call the function, inside the function, I create a new items list, which means that this items list only exists inside the function, and it is not shared between the different function calls. And the same example with dictionaries. Again, I have the config equals none, and inside I'm creating a new instance of config, and I'm incrementing the count, and I'm calling this function again twice. And if I run the code, you'll see dictionary, the first call count is equal 1, second call count is also equal 1. Because now I'm not sharing the dictionary between the different function calls. I'm creating a new dictionary inside the function that only exists in the scope of that function. That is mutable arguments in Python, and now mutable arguments can be wrong, and mutable arguments can be used correctly. Again, follow the standard practice and define your mutable arguments as none to avoid hidden bugs in your code. Like this video if you like this content, subscribe for more content about Python, Django, and AI, and until next time, happy coding!